since I told you could answer, was it 105 through 108 on this sheet, then I'm going to use this sheet to answer it, okay? You already have this outline of the periodic table here for all of these questions. The test is all multiple choice. The midterm test is all multiple choice.
I know it can't be a question that say like, oh, it's the smallest one.
I'm sure I could ask questions, multiple choice questions, for which you have to figure this out first. Okay? And so in order to answer the multiple choice questions on the test, you have to be able to solve the problems. Okay?
Who needs help with these? Who needs help with these?
Dev needs help with these.
All you gotta do is remember that all of them are low to high except for atomic size. That's how I do it, because it's just too much. Like low to high, then you get the atomic size is high to low.
You know, there are a few things that aren't quite perfect with that. Electronegativity does not include the noble gases, for instance. So we have to cut off the noble gases. Okay, noble gases are not included in electronegativity because electronegativity, by definition, is how hard an atom pulls on electrons it shares with another atom. And since noble gases, for the most part, don't share electrons, there's no electronegativity. So the element with the highest electronegativity is right here. It's fluorine. One with the lowest is down here, either cesium or francium. And so you're going to have highest up in this direction, and lowest down here. Okay, 106 asks, instructs you to illustrate on the periodic table outline the general pattern of first ionization energy of the elements. Well, first ionization energy does include the noble gases. So this arrow needs to go all the way up there to helium. So the highest is up there. It takes the greatest amount of energy to remove an electron from helium. Okay, and the least amount of energy to remove a first electron from either cesium or francium. Okay? Pattern of atomic size. Atomic size gets smaller as you go across any row of the periodic table. So it gets smaller in that direction. But it gets larger as you go down this way. Ionic size is a little bit tricky. Okay? Because from about this point over, these are all metals and they're losing electrons. And from this point over, they're mostly nonmetals anyway, and they're gaining electrons. So what happens is there's a difference in the behavior right along this boundary, somewhere right in there. So what happens is, as you go from left to right, from up to that point, they get smaller. Okay? They start out smaller than the corresponding atoms, and they get even smaller going across the road. But along this little boundary right here, where we go from removing electrons to adding extra electrons, this suddenly jumps in size. I mean, it becomes huge by comparison along that boundary, and then continues to get smaller across each row. And just as our earlier pattern with atomic size, they continue to get larger as you go down in a column. So all that's listed in your Unit 2 handout, I believe it is. Huh? Say again. Ionic size what? Well, the ionic size numbers were listed there, right? And there was a three-dimensional periodic table picture there, wasn't there? Yeah, yeah. Okay. Maurice, what's your question?
101 through 102. You can either do all of it or one by one. So like one switch. I'm at.
You mean you can't go to Unit 2 and look this stuff up? And I know. I mean, really. Come on, Sadie. Tell him about it.
When we do these charts on the test tomorrow, is you gonna have them like how you got them, or low to high, like how you got them in the packet? Not these graphs. You gotta draw these.
You have to be able to interpret these graphs in order to answer multiple choice questions on the midterm exam.
Oh, the whole thing is multiple choice.
That's what I said. Yes.
Finally.
You wouldn't know that.
Okay, the representative elements. I mean, we're really kind of wasting time here because you should be asking me questions that you can't find answers to in the packets. And these are like memorization and repeat stuff.
Like right there.
Nobody else is answering another question. I mean, asking another question.
It's in Unit 2. Or sorry, one of them.
In Unit 2 more.
All the graphs behind the video.
I'll find.
So these are alkali metals
Thank you.
right here.
See how quickly we're going through this?
These are alkaline earth metals. Right there. Let's see. These are the transition, what's it called? Transition metals here. And this column right here is where we find the halogens. And this last column over on the right are the noble gases.
What about the inner transition?
Say what now?
What about the inner transition?
Oh, those are down here.
Okay, so there's nothing in between the transition and halogen.
No, we don't have to name those. There are actually names for all these columns. We don't get into it in here. Okay. Metals and nonmetals. There's that stair step that goes right in here. Somewhere out, something like that. I don't know if I've got that right or not, but you. And then metalloids are located right along that. Anything that touches two sides except for aluminum are the metalloids. Okay, so metals are over here, nonmetals are over there, except for hydrogen, because hydrogen actually belongs, in this context anyway, right there.
So you said to the left of this is metal.
Hmm?
Yeah. Oh.
Okay. Well, I haven't finished 104 yet. SP, D, and F sublevels. This is where we move helium over here. And this is S, P, D, and F.
Can I see that paper that you did 95 on?
Say what now?
Can I see the paper you did 95 on?
Yeah. Could you hand that back to, okay. All right.
Or is it cold running away?
Carolyn, you have a question?
Yeah, it's not another problem.
Please give me a different problem.
Okay, it's can you do the naming things for 57 through 59?
57 through 59.
So,
I'm so confused.
All right. Well, that has a charge on it. PO3 with a 3 negative. Where are you going to find something with a charge on it?
Polyatomic, no.
Common ions list, so you just look it up.
No, I was talking
Oh.
about 57.
Oh, okay. And this is made of two nonmetals. So what kind of bonding is going to take place here? Covalent.
Di-nitrogen.
Tetra.
They use the prefixes di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay? And that's for the covalent compounds that are not organic. Okay? An organic would have, yeah.
It's what? Nitrogen.
Is it di-nitrogen tetroxide?
Yes, that's what yes.
For number